Solution video of question 5 of the modules of Morse circle of 2D strength and strain transfer notion. So in this question, we have a rod which is made out of aluminium. It's subjected to the tensile load of 700 newtons and has a diameter of 20 millimeters. And we need to determine the absolute maximum shear strain in the rod on a point on its surface. So first of all, just the material properties for this specific type of aluminium. So properties. We can find that our Young's modulus of elasticity is 73.1 gigapascals, which is the same as 73.1 times 10 to the positive 3 megapascals. We also have the Poisson ratio, 0.33. And the first thing we want to do, we want to find our normal strain equation, which we can find our normal strain in the x component, 1 on Young's modulus normal stress in the x direction minus the Poisson ratio of our stress in y plus stress in x. And if we look at our normal stress, from in here, what we can find is that we only have stress in the x direction, and it's our normal force divided by the area. So the normal force is 700. Area of a circle, we can use pi on 4 times the diameter. And we just write that in meters. Get it in megapascals. 2.228 megapascals. In the y direction, there's no force, so there's no stress, 0. And the same in our z direction, 0. I just realized my equation in here, I wrote that incorrectly. The x, it's supposed to be z, of course. Now that we know that, we just need to input our values, and we'll find that the normal strain in the x component will be our normal stress divided by our Young's modulus. And for our normal strain in the y direction, 1 on Young's modulus, normal stress in y minus Poisson ratio times normal stress in x plus normal stress in z. Again, look at this, rearranging it in y. Again, hopefully you guys can tell that this is a y, not an x. For writing on my end, we will find that our strain in the y direction is just our negative Poisson ratio times the normal stress in x divided by Young's modulus. And lastly, we want to find the strain in the z direction, 1 of Young's modulus. Again, the equation looks similar, just out z minus constant ratio times normal stress in the x plus normal stress in y. Again, we'll find that our strain in the z direction is the same as our strain in the y direction. Let's start with our strain in the x direction, which is our normal stress in x, so 2.228 divided by Young's modulus. Then the 3.1 times 10 to the power of 3, 30.48 times 10 to the negative 6. And then our strain in the y direction, which is the same as our z direction, which is our negative 0.33 times 2.28, sorry, 228 divided by 3.1 times 10 to the power of 3, which gives us negative 10.68. The last thing we want to do is find our max in plane shear strain. Which is simply just our maximum strain minus our minimum strain, which is then just the 30.48 minus 10.68, which again times 10 to the negative 6, which is 41.16 times 10 to the negative 6. And there we go. That concludes this question.